So we are about to build a beautiful shape called a rhombic triacontahedron. There's a fun puzzle, magnetic puzzle, that has that same shape. It's made of 30 rhombic pieces, wedges that fit together magnetically. It's referred to as ball of wax. But we're going to build them out of hypertiles. And here are the rhombuses we're going to use. They're not quite flat. They already have a bit of a bend to them. This is that beak structure that's in so many of the other ones. And we're going to put the connectors off-center to allow it to do a little bit like this. That's going to help flatten this out some and make it a little bit easier. We're also going to do that along the perimeter, that is, have the connectors off-center. So, we need 60 tiles, enough to make 30 of these. I've got 28 made here. 6 of each of 5 different colors, 6 orange, 6 red, 6 yellow, 6 blue, and I'll have 6 green in a bit. I just want to show you how to do this, although it's pretty straightforward. So rather than put the connector in the middle as we would normally do, and by the way, you can do that. You can do the connections in the middle, but if you have a shape you're building that is going to stress the angles, see how these are nice and even across right there? But if this is one that's going to, for instance, do this or this, having that off-center is going to give you a little bit more flexibility. And because this one stresses it in this direction, I'm going to move these connectors down to that second to last position there on both sides. Again, you don't have to, but it just helps to spread the stress. And now you can see how much wider, what a bigger discrepancy you get between one side and the other with those connectors off center. Okay, so there's one. I'll do it one more time here. Again, we're just putting these two together. By the way, don't do spiral connections. These are all going to be zigzag connections. And rather than put it in the center, we're putting it in that second to last position there. Okay, I guess you could say the position that's almost farthest away from the point of the beak, okay, to allow it to allow the beak to talk a little bit. Okay, so at this point we're going to now assemble these kind of like this here, 5 rhombuses, rhombi, around a center, and these are going to be actually with the points, the beaks pointing inward, so like this. But we're going to use 5 different colors, and that's going to be our pattern here. So again, rather than do it like this, okay, we know that this is going to be, that center point is going to be crowded, so we are going to move it, the connections to there. So once you have all the 30 beaks made with the connections farthest away from the beak, or second from farthest, we're now going to make these rings of 5 rhombuses with the connections in close to the center. Okay, like that. I'll show a quick group here, and I'm just going to use 5 different colors. And where it doesn't look like it's going to fit, we're going to fold it like this to make it fit, and that's where the curvature of this is going to come from. So like that, yeah, so it's going to be flexed like this during the course of this, and that's why we put them there. And you see how much wider this is going to be than the inside. The inside is going to be rather close together, but having done the off-centered one there and the off-centered one there helps to spread it so it's not as strained as it would be had we done this one in the center. Okay, so what this is kind of neat, because what I'm going to space these is, you see the red one here? that means I'm going to put a red one here going this way. Okay? So, there to there. Okay. See the yellow one? We'll put a yellow one here. Again, each time we do this, we're going to put the connectors closest to the acute angle as opposed to the obtuse angle of the rhombus. Okay, that's a good way of describing it. Okay, so we got yellow opposite yellow, red opposite red. Here's a blue one. We'll put a blue one here. You don't have to do it this way. You don't have to use this color scheme at all, but I like to have patterns within the patterns, and this is going to be kind of neat because when we're done, we're going to see that the 6 blue, for example, 6 blue rhombuses are going to define the points of an octahedron on this overall structure. Same with the 6 yellows, same with the 6 reds. So we'll have 5 interlocking octahedra inside this triacontahedron. So, green, green. Once you've made that first ring of 5, the rest is pretty straightforward, as long as you always put them opposite. Okay? And we have orange there. We're good for orange here. At this point, ready to start adding on again. I'm going to have 2 more in this ring here. A blue one, and let's see what else, a red one. But again, I want them to be opposite, and I see a blue one here, so I'm going to put the blue here and the red there. Okay, and now that I've explained that, I really feel I can kind of fast forward. So. Okay, I've got just 5 left to add, and here's where they're going to be added. You can see how it's all spiky on the inside. You're not going to have that view in a second, but there's what it's going to look like. Okay, just 2 left to put in there. And here's what I was talking about, by the way, which is what makes this build a little bit harder than others. How they're so crowded together at the 5-way junctures and so spread apart at the 3-way junctures, the 3-way vertices. But having put these off-centered like that allows a pretty decent they're crowded, but they're not like on top of each other. I'll show you what happens at the end of this if you don't have them off-centered like this. You put the connector there, they do start to overlap and get in each other's way. But it does make this build a little bit trickier than normal, okay? There's a couple other builds that are like that. Whenever you're trying to force an angle to be not quite what it wants to be, it's the connector that has to kind of give a bit and be more flexible. So let's see which one we're going to put here. We got just a red one and an orange one, and for one thing, I already see a red one in this group, so I know it's the orange one. Also, see how it's opposite this one here? So we'll actually put this here as well. Okay. Whoop. These are stronger connectors. They're a little bit harder to work with, but they hold the shape together better in the long run, so they're worth it. You can see it's even what I'm having trouble with here, but that's how it goes. Okay. This kind of says it all. We're down to one last one to put in there, but it looks like it's a square hole, but look what I'm trying to put in there. And again, we're going to have to stretch it around to make it fit. So I'll put the 4 connectors already in there where they're supposed to go, and we'll see how challenging it will be, especially because I can't put my hands inside for that last piece. But okay, here we go. So the final piece, it's a red one, and let's see if I can hold this like this. What makes this challenging is you want to hold it with your fingers above and below it, but I can't really do that if it's the last piece to put in, so we just kind of have to, there we go, do our best. So if you're building this and finding a challenge, join the crowd. But it's certainly worth it. It's a satisfying build, and the thing is, once you've made it, it's pretty darn stable. Just one connection left, and there it is. Ta-da! We can go around now and kind of make these all more symmetrical so they look nice and consistent like that, and then look at how far apart these are. So big wide gaps and little tiny gaps. That's why we put the connectors off center. But this is it. It's comparable to this, and as I was pointing out, it's a rhombic triacontahedron. Not a very well-known shape. It's got 30 rhombuses, and I said that I was going to put the colors in a way that has its own neat consequence, and that is, let's just look at the yellow ones. So there's 6 of them. 1, 2, 3, 4, 5, and on the bottom 6. If I have one on the top and one on the bottom, and then these 4 around the perimeter, they define an octahedron. That is, if I took, I guess, the center of each of these rhombic faces and use those to define a new polyhedron, it would be one that has 6 vertices, and that's the octahedron. Okay? The yellows aren't the only ones. Of course, the blues are like that too, as are the reds and the oranges and the greens. So what we end up with then is essentially 5 interlocking octahedra. We had something similar when we had 5 interlocking tetrahedra for another shape, but this one is such that the colors define, each one defines its own octahedron, and they're interlocking, and that's kind of nice. Okay? I said I would show you what would happen if we didn't have the connectors off-centered, and I didn't do it to the entire shape, but just to this one 5-way juncture. I moved the connectors away from this joint and put them more in the center, which makes it harder to have a big gap difference between one end and the other. There still is a difference, but look what that does to the vertex there. They kind of overlap, and it's not quite as nice compared to, for instance, one on the other side that still has them like that. They're touching, but here they are literally overlapping. You can see the green one's on top and the yellow one's on bottom, and there really isn't any other way. So you get these gaps and stuff. So better to have the connectors off center and and alleviate that overlap. Okay? So